All right, let's take a look at the practice test. For the instructions, we're asked to derive the given identities. For the first problem, we have the cosine of a over 2. So let's go back to the handout and let's scroll down to where we have the half angle identities. So this is the one we want, the first one where it says cosine of a over 2 is equal to plus or minus the square root of 1 plus the cosine of a over 2. So where does that come from? Let's scroll back up. We need to go to the last section where we talked about these double angle identities. And we're going to start with this one that says the cosine of 2a is equal to 2 times cosine squared a minus 1. What we're going to do, instead of using a, we're going to use x, because we're going to do a little substitution at the end. Where there's an x, we're going to plug in this a over 2. So let's write out our little double angle identity to get started. So the cosine of 2x is equal to, again, this is 2 times cosine squared x and then minus 1. Now, what you're going to end up doing is getting cosine of x on one side and then everything else on the other. And again, like I just said, you're going to plug in this a over 2 everywhere there's an x. So you can pause the video and try that now, or you can just go through this with me, either way. Since I want the cosine of x on one side by itself, let me add 1 to both sides like this. And so this will give me the cosine of 2x plus 1 is equal to 2 times cosine squared x. Now I'm going to write this on the left and this on the right. So I'm just going to switch the sides. Remember, that's completely legal. So I'm just going to say this is 2 times cosine squared x is equal to cosine of 2x. Instead of putting plus 1 with the formula, it's actually 1 plus this guy here. So 1 plus cosine of 2x. From here, what I would do, since again, I want cosine of x by itself, I'm just going to divide both sides by 2. So I can get rid of this 2 right here. And so now I have cosine squared x is equal to, I have 1 plus cosine of 2x over 2. Now I'm going to use my square root property here. So this side on the left will just be the cosine of x. But over here, you have to remember that you want plus or minus the square root of this guy. So 1 plus the cosine of 2x over 2. So you need this plus or minus here because, again, cosine would be positive in quadrants 1 and 4, and then it's negative in quadrants 2 and 3. Okay, so based on the quadrant that you're in, you would choose the appropriate sign. So that's why you have the plus or minus. Now, we are not quite at our formula. So here we have the cosine of x is equal to plus or minus the square root of 1 plus cosine of 2x over 2. The idea here is that you have x and then you have 2x. So you're going to plug in an a over 2, or you could do theta over 2 or whatever you're working with everywhere there's an x. So basically, you're just going to say that this is the cosine of, let's just say this is a over 2, and this is equal to plus or minus, and I don't think this is going to fit. I didn't give myself enough room. And bring this down here. So the square root of 1 plus the cosine of 2, again, where there's an x, so here and here, you're plugging in a over 2. And then this is over 2 like this. So now this is going to simplify. So this 2 divided by this 2 would be 1. So you arrive at the formula. So this is the cosine of a over 2 is equal to plus or minus the square root of 1 plus, you would just have the cosine of a over 2. All right, let's take a look at problem 2. So now we have the sine of a over 2. So going back to our handout, if we come back again to the half angle identities, so the second one here is what we want. So the sine of a over 2 is equal to plus or minus your square root of 1 minus the cosine of a over 2. So coming back up to the double angle identities, we want the third one that says the cosine of 2a is equal to 1 minus 2 times sine squared a. So let me write this down here. And instead of a, I'm going to use x. So we'll have the cosine of 2x is equal to 1 minus 2 times your sine squared x. Now I'm using x here because, again, what we're going to do is isolate sine of x on the left side. And then what's going to happen is you're going to plug in an a over 2 everywhere there's an x, and you'll get that formula. So if I want to isolate the sine of x, well, what I would do first is let's subtract 1 away from each side, so that would cancel. Let's say now that this is negative 1 plus the cosine of 2x. And I'm just writing it like that because that's the order it's going to end up in. So let's say this is equal to, over here, this is negative 2 times the sine squared x. So now what I'm going to do is just write this one over here. So negative 2 times sine squared x. And this equals -1 plus cosine of 2x. All right, I'm just going to divide both sides by -2. And I'm going to split this up here to make it easier to understand. This will cancel. So now I have my sine squared x, and this equals, basically I'm just going to put negative over negative as positive. And so I'm going to write this as 1/2. Positive over negative would be negative, so let's put minus. You have cosine of 2x over 2. Now, a lot of people try to cancel this with this. That is illegal, okay? This is on the inside here, right? So this is the cosine of 2x and then divided by 2. So don't go through and cancel this with this, okay? That's illegal. You don't want to do that. So now what I would do from here is say that this is sine squared x is equal to, I'm going to write this with a common denominator. Let me scooch this down just a little bit. This would be 1 minus the cosine of 2x over the common denominator of 2. Let's come to a fresh sheet here so we don't run out of room. So now I would just use my square root property. So you would have the sine of x is equal to, again, you need that plus or minus because with sine, it's positive in quadrants 1 or 2, and then it's negative in quadrants 3 or 4. So let's go ahead and say this is the square root of 1 minus the cosine of 2x over 2. Now, the last thing, you have an x here and an x here. You're just going to plug in an a over 2 or a theta over 2 or whatever you want to use. So that would give me the sine of a over 2. Let me make this s a little bit better here. And this is equal to plus or minus the square root of 1 minus the cosine of 2 times your a over 2. So see how this is on the inside here? So you can cancel this. This is okay because it's on the inside of what you're trying to do, okay? If you had cosine of 2x over 2, you cannot cancel those 2's there. But if you have the cosine of 2x over 2 like this, right, it's inside here, then you can cancel the 2's. So hopefully you understand the difference between those two different situations. I know that trips up a lot of people. So let's go ahead and just cancel this right now and say that this is the cosine of a, and then this is all over 2. So this is your formula. The sine of a over 2 equals plus or minus the square root of 1 minus the cosine of a over 2. Okay, let's look at problem 3. So here we have the tangent of a over 2. And going back, let's look at this guy right here. So for the half angle identities, you actually have 3 of them for the tangent of a over 2. I'm just going to do the first one here where it says the tangent of a over 2 is equal to plus or minus the square root of 1 minus the cosine of a over 1 plus the cosine of a. And what I'll do here is say that this is the sine of a over 2. So we just did that one over the cosine of a over 2. So this would be equal to, for the sine of a over 2, we said this was plus or minus the square root of 1 minus the cosine of a over 2. And then this would be over your cosine of a over 2. So this is plus or minus the square root of 1 plus the cosine of a over 2. Okay, so how are we going to simplify this? It's actually pretty easy overall. First and foremost, if you have plus or minus over plus or minus, just think about the fact that you could either have the same signs or different signs, so you're going to end up with plus or minus again. Okay, so that's very simple to understand. If that's confusing for you, you can just try things out. You could do something like, okay, what if I had the square root of 9 times, let's say, the square root of 4? Well, principal square root times principal square root, this would be 3, this would be 2, that would give you 6. If you now change this to a negative, well, now you would have a negative. And then if both of these were negatives, well, now you go back to having a positive. Okay, so if you see plus or minus times a plus or minus divided by a plus or minus, you end up with a plus or minus, right? Because you're either getting the same sign or you're getting different signs. So once you have that established, let me put plus or minus here, then you can make a big square root. And again, if you have the square root of something divided by the square root of something else, so something like the square root of a over the square root of b, this is the square root of a over b. Okay, so you can just combine it like that and say that this is 1 minus the cosine of a over 2. Let me come down here a little bit. And actually, let me make this square root sign a lot bigger. So all the way like this. So this is divided by 1 plus the cosine, let me make that a little bit better there, of a over 2. And let me drag this down here so it's a little bit better formatted. Now what you would do, since you have one fraction divided by another, you would just say this is plus or minus the square root of 1 minus the cosine of a over 2. So the top fraction here, leave that alone. You're going to multiply by the reciprocal of this bottom fraction here. And I'm talking about in terms of this complex fraction. This is the fraction in the numerator. This is the fraction in the denominator. So leave this one unchanged, multiply by the reciprocal of this one. So I'm going to put the 2 up here, and then the 1 plus the cosine of a down here. Maybe I can make the s a little bit better. And so the 2's are going to cancel. And so what does this give me? Well, at this point, I have my formula. So it's going to be plus or minus the square root of 1 minus the cosine of a over 1 plus the cosine of a. So that's what we're looking for. All right, for the next few problems, the instructions tell us to find the exact value. And for problem 4, we have the sine of 345 degrees. So for this one, you could use your half angle identity. Again, the sine of a over 2 is equal to this plus or minus the square root of 1 minus the cosine of a over 2. But what you would want to do first is think about, okay, if I want to use a over 2, well, I need to double this first and then divide by 2. But in this particular case, if I double 345 degrees, I'm going to end up with 690 degrees, and I like to work with something that's between 0 and 360 degrees. So what I would do here is think about the concept of a reference angle, which we learned about earlier on in the course. So if I'm in quadrant 4, the reference angle is 360 degrees minus your angle. So in this case, 360 degrees minus 345 degrees, so it's 15 degrees. So this would be equal to the sine of 15 degrees. But again, you got to think about what quadrant you're in. I'm in quadrant 4, so I know that sine is negative, right? So I want to put the negative of the sine of 15 degrees. So let's say this equals now. It's going to be a little bit easier to work with our formula. Let's say the negative of, I'm going to go the sine of, I'm going to double this. So 15 degrees doubled or times 2 is going to be 30 degrees. And then I'm just going to divide it by 2 like this. Okay, so this would be equal to, again, you have the negative of, with your formula, you have the plus or minus, but I know that in this case, it's going to be a negative, right? Because this angle that I'm working with, the 345 degrees, is in quadrant 4. So that's why I want to make sure I have that negative. That's why I have it here and here and here, okay? So then I would just put the square root here, and then the formula is 1 minus the cosine of whatever angle you're working with. Now, this is going to be this guy right here in this position, in the top position. Remember, it's a over 2, and this is your a that's going right here. So this is going to be 30 degrees, and then this is over 2. So real simple formula to work with. Let's come down here and just say this is equal to the negative of the square root of 1 minus, we all know the cosine of 30 degrees is square root of 3 over 2. So this is square root of 3 over 2. And then this is over 2. Let me make this a little bit longer here, so that's more consistent. So let me move this out here. And actually, let me move this down. Okay, so the quickest way, I think, to simplify this is to multiply the numerator and denominator of the complex fraction by 2. And so what is that going to give me? So the negative of the square root, 2 times 1, let me show this here. 2 times 1 is 2. And then minus, if you do 2 times the square root of 3 over 2, the 2's are going to cancel, so you just get the square root of 3. And then down here, 2 times 2 would give me 4. So let's break this up and say this is the negative of the square root of 2 minus the square root of 3 over the square root of 4 is 2. So this would be my final answer here. So it's the negative of the square root of 2 minus the square root of 3 over 2. All right, let's take a look at problem 5. So here we have the cosine of 112.5 degrees. So again, I would just double this angle and divide by 2. That way I can use my half angle formula. So 112.5 degrees times 2, that's going to give me 225 degrees. So this is the cosine of 225 degrees divided by 2. Now, whenever you use the formula, again, you always think about the original angle. Don't worry about this angle up here. Okay, this is just for us to plug into the formula. I am trying to find the cosine of 112.5 degrees. So think about the sine based on where is that guy. So this guy right here is going to be in quadrant 2, so cosine is negative. So this is equal to the negative of the square root. This is 1 plus the cosine of, this is your a up here, so this is 225 degrees, and this is over 2. All right, at this point, I think we know what the cosine of 225 degrees is. You have a 45-degree reference angle, and you're going to be in quadrant 3. So the cosine of 45 degrees is square root of 2 over 2. In quadrant 3, cosine is negative. So this would be the negative of the square root of 2 over 2. So let's say this is equal to, we'll have negative square root of 1 and then minus the square root of 2 over 2. And then this is over 2 like this. You need to make these longer. So let me do this like that. And then just like I did in the last problem, we're just going to multiply this by 2 over 2. And so this is going to get distributed here, and this will go here. So this equals the negative of your square root. 2 times 1 is 2, and then minus the 2's would cancel, so you just have the square root of 2. And this is over 2 times 2, which is 4. So again, easy to break this up and just say this is the negative of the square root of 2 minus the square root of 2 over the square root of 4 is 2. And you can move this out in front if you want. So the negative of the square root of 2 minus the square root of 2 over 2. All right, let's take a look at problem number 6. So here we have the sine of pi over 12. Now again, if you have trouble working with radians, you can always convert this over to degrees. For these types of problems, it's probably not necessary because all you're doing is doubling this angle and dividing it by 2, right? So you can do the quick conversion if you need to. So let me say this is pi over 12 times 180 degrees over pi. So this is going to cancel. 180 divided by 12 is 15. So this is 15 degrees. So this right here would work out to be the sine of, again, you could do 30 degrees divided by 2, but I'm just going to use these radians here. So I'm just going to go ahead and say I'm going to double this. So essentially what you'd have is 2 times pi over 12. This would cancel with this and give me a 6 down here. So this would just be pi over 6 and then over 2 like this. Okay, so that's all you have to do. So same thing, just working with radians. So again, plus or minus, but in this case, pi over 12, 15 degrees, that's going to be in quadrant 1. So you want the principal square root. So the principal square root, and then we would say this is 1 minus your cosine of pi over 6, and this is over 2. Now the cosine of pi over 6, or the cosine of 30 degrees, is square root of 3 over 2. Let me just erase this here. So this is the square root of 3 over 2, and maybe I can make that a little bit better here. So this is square root of 3 like that. So I'm just going to multiply this by 2 over 2. And again, just distribute this here, and distribute this here. Okay, so this is going to end up being the square root of 2 times 1 is 2, and then minus the 2's would cancel, so you have the square root of 3, and this is over 2 times 2 is 4. So I'm just going to break this up and say this is the square root of 2 minus the square root of 3 over the square root of 4 is 2. Okay, let's take a look at problem 7. So here we have the cosine of 9 pi over 8. So again, you could convert this over if you need to. So I'll multiply this by 180 degrees over pi. I don't recommend it at this point. I think you should get used to working with fractions. So the pi's are going to cancel. If I do 180 divided by 8, I get 22.5. Let me just do this as a decimal here. And 22.5 times 9 is going to be 202.5. So this ends up being, I'm just going to write this here for reference, 202.5 degrees, in case you need it. Now, if you want to work with this in terms of radians, which is what I suggest, I would just say this is the cosine of, again, just double this, or you can double this if you need to work with degrees. So this is going to end up being 9 pi over 8 times 2. So this would cancel with this and leave me a 4 down here. So this is 9 pi over 4, and then this is going to be over 2. So we'll say this is equal to, again, your 202.5 degrees, that would be in quadrant 3. So in quadrant 3, cosine is negative. So you want to put the negative of the square root of, it's going to be 1 plus the cosine of, again, this angle right here, which is 9 pi over 4. And then this is over 2. Now for the cosine of 9 pi over 4, I would get the coterminal angle. So we think about 9 pi over 4. That's greater than 2 pi. So I'm going to subtract away 2 pi. So to get this in terms of having a denominator of 4, you could just write out 2 pi and then multiply by 4 over 4. So this would be 8 pi over 4. So 8 pi over 4. So the coterminal angle would be pi over 4, which is 45 degrees. So essentially the cosine of 45 degrees, or pi over 4, is square root of 2 over 2. So this ends up giving me the negative of the square root of 1 plus the square root of 2 over 2, and then this is over 2. So I'm just going to multiply by the 2 over 2 so that this denominator gets cleared out. So let's multiply here and here and here. And let's see what we end up with. So the negative of the square root of 2 times 1 is 2, and then plus square root of 2 over 2 times 2. The 2's would cancel, and you just get the square root of 2. and this is over 2 times 2, which is 4. So to finish this up, I'll say this is the negative of the square root of 2 plus the square root of 2, and this is over, the square root of 4 would be 2. All right, for the next few problems, the instructions tell us to find the exact value. So for problem 8, we're told that theta is greater than 180 degrees and less than 270 degrees. So that means we're going to be in quadrant 3, and this is for theta, not theta over 2. Then tangent of theta is given to us as 4/3. We want to find the cosine of theta over 2. So if you get this type of problem, the first thing you need to figure out is, where does theta over 2 lie? This is theta. You need to figure out theta over 2. So just start with theta being greater than 180 degrees and less than 270 degrees. And all we're going to do is divide each part here by 2 and simplify. So 180 degrees divided by 2 is 90 degrees. And then for 270 degrees divided by 2, that's 135 degrees. So what this tells me is that your theta over 2 is going to be greater than 90 degrees and less than 135 degrees. So I'm going to be in quadrant 2. Now, cosine is negative in quadrant 2. So just keep that in mind when you're trying to figure out what sign to use. So to find the cosine of theta over 2, we're going to use our formula, which is plus or minus in this case, because again, we're in quadrant 2 for theta over 2, and cosine is negative. I'm going to put the negative of the square root of 1 plus the cosine of, in this case, it's going to be theta over 2. So I just need to figure out what is the cosine of theta, plug in, and I'll be good to go. And we are told that the tangent of theta, which again is y over x, is equal to 4 over 3. Now that doesn't mean that y is 4 and x is 3. Again, you have to think about what quadrant theta is in. We said that theta was in quadrant 3. So in quadrant 3, your tangent is going to be positive, and that's because your y is negative and your x is negative. So in reality, this is a negative 4 and this is a negative 3. So coming down here, we would say that y is equal to negative 4 and x is equal to negative 3. So just keep that in mind. Now we need to figure out the r value here. And a lot of you can just eyeball this and see it's going to be 5, right? Because basically, forget about the negatives here. You have a 3, 4, 5 right triangle. So at this point, you can just put r as 5, and you could say that, okay, well, cosine of theta is going to be x, which is negative 3, over r, which is 5. So this is negative 3 over 5. Again, if you need to do this the long way, you can always say that r is equal to the square root of x squared plus y squared. So x here is negative 3 squared is 9, and then plus y here is negative 4 squared is 16, so 9 plus 16 is 25, and if you take the principal square root of 25, you do get 5. So that's where we're getting that r value of 5 from. Again, if you notice you have a 3, 4, 5 right triangle, you can just skip all that stuff. Okay, so now that we know the cosine of theta is negative 3/5, let me erase all of this and come back up here. I'm just going to plug in right there a negative 3/5 and basically just simplify, and we'll have our answer. So we'll come down here and say this equals the negative of the square root of, again, you could get a common denominator or you could just multiply by 5 over 5, whatever you want to do. So this is going to get distributed here and then here. 5 times 1 would be 5, and then minus 3/5 times 5 would just be 3. And this is over 2 times 5, which is 10. So this would be equal to the negative of the square root of 5 minus 3, which is 2, over 10. So that's going to end up being 1/5. Let me just do that right now. And what I'll do is I'll just split this up now and say this is the negative of the square root of 1 over the square root of 5. So the square root of 1 is 1. And really all we need to do is rationalize the denominator. So say this is times the square root of 5 over the square root of 5. So your final answer for the cosine of theta over 2 would be the negative of the square root of 5 over 5. All right, let's take a look at problem number 9. So here we're given that theta is greater than 180 degrees and less than 270 degrees. So again, that's telling me that theta, not theta over 2, but theta is in quadrant 3. So let me put this over here. That theta divided by 2 is greater than 180 degrees divided by 2 would be 90 degrees. And then we'll say, and it's less than 270 degrees divided by 2 would be 135 degrees. So theta over 2 is in quadrant 2, whereas theta is in quadrant 3. So here we're given tangent of theta. Notice it's positive because tangent is positive in quadrant 3. And this is 1/4, right? But essentially what's happening is in quadrant 3, the y values are negative and the x values are negative. So you have a negative over a negative, which gives you a positive. When we get to the tangent of theta over 2, again, theta over 2 is in quadrant 2. So the tangent values there will be negative. When I go ahead and do my formula, I want the negative of the square root. Let's come down here and we'll go ahead and say, first and foremost, that you could pick any of these 3 last formulas here for the tangent of a over 2. I think that although it's more difficult to simplify when you work with this first one here, you only need to find the cosine of, in this case, theta. So if I only need one of them, for myself, it's a little bit quicker. Maybe you have a hard time simplifying with that, so you could use the other 2. It'll be a little bit easier for you. So let's just go ahead and first find the cosine of theta. And again, when we think about this, theta is in quadrant 3. So I know my cosine value is going to be negative. Now, thinking about this, we have the tangent of theta is given to us as 1/4. Remember, this is y over x, but I'm in quadrant 3, so my y values are negative and my x values are negative. So you can do this and find your r as the square root of x squared plus y squared. So -4 squared is 16 plus -1 squared is 1. So this would be the square root of 17 like this. And so the cosine of theta would be x, which is -4, over r, which is square root of 17. You would multiply the numerator and denominator by the square root of 17. So you could rationalize the denominator there. And essentially what you would have is the negative of 4 times square root of 17 over 17. Now, if you don't like using this method, you can always use an identity. Remember, you could have done this by saying that tangent squared theta plus 1 is secant squared theta. And then you could just solve that for the secant of theta, take the reciprocal, and you'd have the same thing here for the cosine of theta. So let me get rid of this. And I'm just going to scooch this up here. So we know what the cosine of theta is. Now our goal is to find the tangent of theta over 2. Now again, this is in quadrant 2. So I want to say this is equal to the negative of the square root of, again, if we go back, it's 1 minus the cosine of a over 1 plus the cosine of a underneath the square root symbol. So let's go ahead and say this is 1 minus the cosine of, in this case, is theta, is the negative of 4 times square root of 17 over 17, minus a negative would be plus a positive. So this is 4 times square root of 17 over 17. Then this is over. Down here, this is 1 plus your cosine of theta. Again, since this is a negative, we'll write minus 4 times square root of 17 over 17. Okay, let's slide down here a little bit. This one's going to be a little bit tricky to simplify. Let me start by just multiplying the numerator and denominator of this complex fraction by 17. That way we can clear out the denominators to get things started. So let's say that this is equal to the negative of your square root. 17 times 1 is 17. And then 17 and 17 here, the denominator would cancel. So this is plus 4 times square root of 17 over 17 times 1 is 17, and then minus, and then here 17 and 17 would cancel. So you'd have 4 times the square root of 17. Now for the next step, I don't want to end up with a radical in the denominator. So what you would do, remember, if you have 2 terms down here and one of them has a square root, you can use that trick where you multiply the numerator and denominator by the conjugate of the denominator. So this will be multiplied by 17 plus 4 times square root of 17 over 17 plus 4 times square root of 17. So this is the same non-zero number over itself, so it's just 1. Just like I'm multiplying by 1, so no big deal. So let's put equals here. I'll put the negative of the square root of, let me wrap this in parentheses, so this is crystal clear what we're doing. So this right here, you can use your formula, x plus y quantity squared. So the first guy squared, 17 squared is 289. And then plus 2 times the first guy times the second guy. So 2 times 17 times 4 times square root of 17. So 2 times 17 is 34. And 34 times 4, that's going to be 136. So this would be 136 times the square root of 17. Like this. And then you go plus your last guy squared. So you would have to square 4, which is 16. And then multiply that by the square of the square root of 17, which is going to be 17. So 16 times 17 is 272. Okay, before I go any further, 289 plus 272, that's 561. So let's just write that right now. In the denominator, it's a little bit less work because you have a minus b times a plus b. So you can square a, so a squared, 17 squared is 289, and then subtract away the square of b, right? So we just did this. 4 squared would be 16, and then times the square root of 17 squared is 17. 16 times 17, again, is 272. So what I'll do here is say 289 minus 272, that's going to be 17. So let's write that down there. So to finish up the problem, what I would do is check, is 561 divisible by 17? Well, yeah, 561 divided by 17 is 33. And then 136, is that divisible by 17? Well, yeah, 136 divided by 17 is 8. So you could say this is the negative of the square root of, I'm going to factor out a 17 from the numerator. So this would be a 33 here, and then plus an 8 times square root of 17 here. And this is over 17. So I'll cancel this with this, and I'll report my final answer. So this is the negative of the square root of 33 plus 8 times the square root of 17. All right, let's take a look at problem 10. So here, theta is greater than 180 degrees and less than 270 degrees. So theta is in quadrant 3. And we already know how this works out because the previous two problems had the same setup. So theta over 2 would be greater than, again, divide this by 2, you get 90 degrees. We'll say, and it's going to be less than, divide this by 2, you get 135 degrees. So theta is in quadrant 3, theta over 2 is in quadrant 2. So let's come down here. We have our sine of theta is given to us as negative 4 over 5. So the sine of, in this case, theta over 2 is equal to plus or minus the square root of 1 minus the cosine of theta over 2. So let's say this is equal to, again, we're going to be in quadrant 2. In quadrant 2, the sine value is positive. So this is the principal square root of 1 minus the cosine of theta over 2. Now, what's my cosine of theta? A lot of you can figure this out really quickly. Again, theta is in quadrant 3. Cosine is going to be negative there. If the sine of theta is negative 4/5, you should know at this point that the cosine of theta is going to be negative 3/5. Why? Because again, you're working with a 3, 4, 5 right triangle. So the negative of a negative is a positive. So this is plus 3/5. And again, if you want to do this the long way, there's so many ways you can do this. You can use sine squared theta plus cosine squared theta equals 1. You could do the fact that you have sine of theta is equal to negative 4/5. So you know that in quadrant 3, the x values are negative and the y values are negative. So you can say that your y here is negative 4. Your r here is going to be 5. And your x here is going to be negative 3. And again, you can just do r is equal to the square root of x squared plus y squared. So negative 3 squared is 9 plus negative 4 squared is 16. 9 plus 16 is 25. So r is the principal square root of 25, which is 5. So again, that's where that's coming from. Hopefully at this point, when you start seeing that, something with a special right triangle involved, you can quickly get the value. So what I'll do here is multiply this by 5 over 5. So this gets distributed here. So we'll say this equals the square root of 5 times 1 is 5. And then plus 3/5 times 5 is just 3. Let's just say 5 plus 3 is 8 now. And then this is over. 5 times 2 is going to be 10. So for 8 over 10, they're each divisible by 2. Let's just go ahead and say that's going to be 4/5, right? 8 divided by 2 is 4. And then 10 divided by 2 is 5. So let's write this as the square root of 4, which is 2, over the square root of 5. You need to rationalize the denominator, so multiply by the square root of 5 over the square root of 5. Let's make that 5 a little bit better there. And so the final answer for the sine of theta over 2, this is going to be 2 times square root of 5 over 5. All right, let's take a look at problem number 11. So here we're given that theta is greater than 90 degrees and less than 180 degrees. So theta is in quadrant 2. Now we're given that cosine of theta is negative 11 over 17. And that makes sense because cosine values are negative in quadrant 2. But in terms of theta over 2, we're trying to find the sine of theta over 2. So that would be where? So theta over 2 is greater than 90 degrees divided by 2 is 45 degrees. And it's less than 180 degrees divided by 2 would be 90 degrees. So theta over 2 is in quadrant 1, whereas theta is in quadrant 2. So keep that in mind. So sine of theta over 2, again, if you go back, the sine of theta over 2 would be equal to plus or minus the square root of 1 minus the cosine of theta over 2. So let's say that this is equal to, again, we're going to be in quadrant 1 for this theta over 2. Let me make this 5 a little bit better. Sort of looks like a 3 there. And then I'll say this is the principal square root of, you have 1 minus the cosine of theta. Now the cosine of theta is negative 11 over 17. Minus the negative is plus a positive. So let's put plus 11 over 17. And this is over 2. So I'm just going to multiply this by 17 over 17. So distribute this like this. And we'll say that this is the square root of 17 times 1 is 17. And then plus 11 over 17 times 17 would just be 11. So 17 plus 11 is going to be 28. And this is over 2 times 17, which is 34. Now, 28 divided by 2 would be 14. And then 34 divided by 2 would be 17. So this gives me the square root of 14 over the square root of 17. So I'm going to multiply this by the square root of 17 over the square root of 17. So this equals 14 times 17 is 238. So this would be the square root of 238 over square root of 17 times square root of 17 is 17. So your sine of theta over 2 is the square root of 238 over 17. All right, for the next few problems, the instructions tell us to verify each identity. So for problem 12, we have secant squared theta over 2 is equal to 2 over 1 plus cosine of theta. So I would definitely say that this side right here is simpler. So let's flip this and say 2 over 1 plus the cosine of theta. So that's what we're trying to get a match on. So this would be equal to, let's just write this. So the secant squared of this theta over 2. So the first thing I'm going to do is say that this is 1 over my cosine squared of theta over 2. Now I think it's probably better to write this like this so it's crystal clear what's going on. Now the next step, if I think about the cosine of, let's say, theta over 2 is equal to plus or minus the square root of 1 plus the cosine of theta over 2. So let's plug that in for the cosine of theta over 2. And again, the squared here is on the outside. That's why I wrote it like that so it's crystal clear what we're going to do. So we'll say this is equal to 1 over. Again, I'm going to wrap this and square it like this. This is plus or minus the square root of 1 plus your cosine of theta over 2. So let's say this equals 1 over. If I square this guy here, I'm just left with the radicand. So I'm going to have 1 plus cosine of theta over 2. And then basically the last thing here is just to say that I have 1 divided by this. So I'm going to write this as 1 times the reciprocal of this. So 2 over 1 plus the cosine of theta. And let's just finish this up and say this is 2 over 1 plus the cosine of theta. And we're done. Okay, let's take a look at problem 13. So here we have sine squared theta over 2 is equal to tangent of theta minus sine of theta over 2 times the tangent of theta. So again, lots of different ways to work this. I'm going to consider this left side more simple. And so what I'm going to do is work on this right side here. And so to do this, I'm going to multiply the numerator and denominator by the cotangent of theta. So let's write this out. The tangent of theta minus the sine of theta over 2 times the tangent of theta, so times the cotangent of theta over the cotangent of theta. Now, you can do this a different way. The reason I'm doing this is because the cotangent of theta times the tangent of theta is going to give me 1, so I'll be able to get a 1 here and a 1 down here. And then sine of theta times cotangent of theta is cosine of theta. So let's come down here and do the cotangent of theta times the tangent of theta. So I'm just distributing this here. And this is going to go here. And then minus the sine of theta times the cotangent of theta. This is over 2 times the tangent of theta times the cotangent of theta. Let me make this theta a little bit better there. Cotangent of theta times tangent of theta in each case is going to be 1. So that's 1 there. Sine of theta times cotangent of theta. Again, you could write this as the cosine of theta over the sine of theta to make that crystal clear. This is going to cancel, so you have the cosine of theta. So this is going to be 1 minus the cosine of theta over 2. We want sine squared of theta over 2. So sine squared of theta over 2. How can we get that? If you just had the sine of theta over 2, that would be equal to what? This is plus or minus the square root of 1 minus the cosine of theta over 2. Right, I'm just getting this, again, from the handout here. So the second guy, sine of theta over 2 is equal to plus or minus the square root of 1 minus the cosine of theta over 2. Now what I want is sine squared of this guy. Again, it's probably easier just to notate it this way. So I want this guy. Well, basically I'm already there, right? So if I go plus or minus the square root of this guy squared, right, it's going to cancel the plus or minus square root part, and I'm just left with this. So all I really need to do is say this is plus or minus the square root of 1 minus the cosine of theta over 2, and then I'm just going to square this to undo that, right? So I'm right back to that. So once I do this step here, I can replace this with my sine of theta over 2. Again, being squared, you could do it like this, but the original notation was like this. I know a lot of people get confused by that, so I'm just going to say this is sine squared of theta over 2, so we're done.